A white dwarf is a dense, compact stellar remnant that forms after a star exhausts its nuclear fuel and goes through the final stages of its evolution. It is one of the possible endpoints for stars with low to medium mass, about 0.1 to 8 times the mass of our Sun. Here's a brief overview of the life cycle of a star leading up to the formation of a white dwarf. Stellar main sequence. A star spends most of its life in the main sequence phase, where it fuses hydrogen into helium in its core, releasing energy that counteracts gravitational collapse. Red giant phase. As a star exhausts its hydrogen fuel in the core, it begins to burn helium in a shell around the core. This causes the outer layers of the star to expand, and it becomes a red giant. Helium fusion. In stars with low to medium mass, up to about 8 solar masses, the core temperature never gets hot enough to fuse elements beyond helium. Eventually, the red giant sheds its outer layers, forming a planetary nebula, and the remaining core becomes a white dwarf. Characteristics of a white dwarf. High density. White dwarfs are incredibly dense. Although their mass is comparable to that of our Sun, they typically have a size comparable to Earth. This extreme density is a result of gravity compressing the matter. Cooling and dimming. White dwarfs no longer undergo nuclear fusion in their cores, so they have no internal heat source. Over time, they gradually cool and dim as they radiate away their residual heat. Electron degeneracy pressure. What prevents a white dwarf from further collapse is electron degeneracy pressure. This is a quantum mechanical effect where electrons become packed so tightly that they resist being squeezed any further. No nuclear reactions. As mentioned earlier, white dwarfs have exhausted their nuclear fuel, so they are no longer undergoing fusion reactions. Carbon and oxygen core. The majority of a white dwarf's composition is carbon and oxygen. This is the result of nuclear fusion processes that occurred during the star's earlier stages. It's important to note that white dwarfs are just one type of stellar remnant. For more massive stars, when the core runs out of fuel, it can undergo a supernova explosion, leaving behind either a neutron star or a black hole. The exact outcome depends on the initial mass of the star.